So far, we've talked about reflections over the x-axis and reflections over the y-axis. In this next class example, we're going to apply each one to the graph of a radical function. Now, I want to look ahead to part A, where it's going to ask us whether it matters in which order we apply these reflections. I want you to think about that as we work through this. First, let's just arbitrarily say that we will reflect over the x-axis first and then the y-axis. Try it yourself before clicking through the animations. So, in our reflection over the x-axis, we see that because there were no points on the x-axis, which is the axis of reflection, there will be no invariant points. Every point's y-coordinate has been changed from positive to negative. In our reflection over the y-axis, the horizontal one, we've changed the x-coordinates from being positive to negative. Again, no point was on the axis of reflection, so there are no invariant points. Now, does it matter whether we reflect over the x-axis first or the y-axis first? The answer here is no, and there's a really important reason. I want you to understand that when we reflect over the x-axis, that's our vertical reflection, it is a vertical transformation. It has no effect on the x-coordinates or the domain of the graph. And when we then reflect over the y-axis, the opposite is true. It's a purely horizontal transformation. So if you think of this, the graph has a domain and the graph has a range. And when we affect one without affecting the other, why would it matter in which order we do so? So whatever's going to happen to the domain is going to happen whether we do it first or second. And whatever's going to happen to the range is going to happen whether we do it first or second. It is important in this course to remember the order when treating multiple transformations on the domain or multiple on the range. For example, to have a horizontal translation and a horizontal reflection, it is critical to treat one before the other, depending on the circumstance. But in the case of a vertical transformation and a horizontal transformation, it should not matter in which order we apply them. Now, in order to state our transformed equation, we're going to see both happen to the equation. So we're going to replace x with negative x, and at the same time, we're going to replace that y with negative y, and then multiply the entire equation through by negative 1. So you'll notice here that the x under the radical sign has a negative coefficient now, and that there's also a negative not only in front of the radical, but in front of a bracket that includes the radical and that plus 1. When we simplify this, that negative out in front multiplies to the positive 1 to make it a negative 1. It cannot multiply into the radical for reasons having to do with how square roots interact with their coefficients. You know, you couldn't take a negative 1 in the coefficient and distribute that into the root for a square root. Excuse me, into the radicand for a square root. So, looking at our green transformed graph, we can see that the domain is the opposite of what it was initially. It used to be all values greater than positive 3. Now that we've reflected it, it's all values less than or equal to negative 3. Similarly, our original range was all values greater than or equal to positive 1. Now that we've reflected it, it is all values less than or equal to negative 1. I hope that made sense. Kind of a tricky idea about order mattering or not, because in some cases it does and it's very important, but here it wouldn't make a difference.